Hi, I'm Jan Ozer. I'm here today with Alex Kruglov from Elecard. Alex is the product manager of StreamEye Studio, which is a bitstream analysis tool. He's also going to show us Boro, which is a tool I haven't seen that is for QoE and QoS monitoring. Thanks for joining me, Alex.
Thanks for having me.
So what are you here to show us today?
Today I'd like to show some practical tips for troubleshooting streaming issues.
So before you jump into the products, tell us a little bit about Elecard.
So Elecard is already 30 years on the market. We have started as the codec developers 30 years ago. And then we started developing our own tools for analysis for our internal, first for our internal encoder developers. And then we start providing it on the market. That's how StreamEye Studio appeared on the market, and then Boro.
Okay, so tell us about StreamEye Studio.
So StreamEye Studio is a set of tools for file-based analysis. It has 5 products inside, and the main products are StreamEye, which is for deep video bitstream analysis. Next one is a Stream Analyzer, which was designed to transfer stream validation and checking their different containers. And the third one is Video Quality Estimator, which is for measurement of objective video quality metrics. The last one we have YV Viewer, just to check the uncompressed YV data, which is typical for encoder developers, and Quality Gates, just to check their similarity between different video bit streams with different resolutions, different frame rates, etc.
Okay, and what's StreamEye Studio cost, and do you sell the products individually, or is it bundle only?
We can sell it individually, or we can sell it as a bundle. It depends on the customer. And then the price will depend on the number of video formats that you need. There typically is a MPEG, AVC, and HVC, but if you need additional one like AB1 or VVC or AVS3, we can provide it as add-ons as well.
Okay. And tell us about Boro.
And Boro is our system for live monitoring. So it consists of 2 parts. The first one is tiny application that we call it Boro. They could be deployed from any part of the network, and they will work locally and monitor the video streams and channel locally. Then we have the second part, which is Boro server, which aggregates all the statistics and errors and warnings from all of the locations. So via the Boro server, we can control entire the chain of the channel and of all of our services in one location.
Okay, cool. And how do you charge for Boro?
We have 2 models. We have subscription model, and the price will depend on the number of channels that you need to monitor monthly. And the second model is solution, when you deploy the entire Boro system on your prem. These are the desktop interface of StreamEye Studio and the web interface of Boro. And our tools are widely used by different groups of users. And the big group is encoder developers, as well as vendors of streaming solution. The second big group is IPTV operators and broadcasters, the companies who use the solutions from the first group. Also, our tools are used by forensic labs and universities. But today I'm going to focus on OTT and IPTV operators and the engineers' regular tasks. These are typical tasks for operation engineers of IPTV or OTT broadcaster. They usually need to tool for quality control and encoding optimization. They troubleshooting and looking for the error location. They need to check the standard compliance of their file-based streams or live channels, as well as ad insertion control. And for that purposes, we provide StreamEye Studio file-based tools and Boro. Then we can. I just want to go through the typical cases for our users, for our customers. And the first one is quality control and encoding optimization. Let's imagine we have the regular Full HD resolution AVC stream that we are broadcasting, and the regular bitrate is 7 megabits per second. However, their operation engineer specified a target bitrate and left the rest of encoder settings by default. And as a result, we have customers who are complaining about streaming quality. And what can we do in that with that task? So let's adjust encoder settings and optimize while having or keeping the same bitrate. And for that purpose, we will use their file-based StreamEye analyzer. So first of all, we can dump the file, open it in StreamEye, and check their current version of settings for the encoder. And then we can play with the regular encoder settings. And what we actually done, we added 4 different variants of encoder settings, and here is the table with them. Then we check every file in the StreamEye just to ensure that the settings that we set in encoder suits our expectations and what we actually did on the encoder side. But their task is to not just to optimize the encoder, we also need to check whether the quality is better or worse after our work. And for that purpose, we can use any objective video quality metrics. And we have the video quality estimator, which is part of StreamEye Studio. In that application, we can estimate any objective quality metrics. I just selected the most common PSNR, VMAF, and SSIM. So for every file, for every settings, we estimated metrics. And we can see on the plot how the metric score rise with their more advanced settings on the encoder side. So the regular workflow, the higher the metric score is, the better the quality. So based on such scales, we can choose their variant number 4. However, we enabled the look-ahead feature of the encoder, so using such option, the encoder will have to check further frames for better predicting the current one. So that will definitely lead to adding the latency. So I suppose that their version number 3 is like the optimal version for encoder settings. At least we increase the video quality. For PSNR is 2 decibel. It's quite incredible, I would say.
Okay, and this would be a live type scenario?
Usually it's for file-based analysis, because to estimate any video quality metric, we need the reference. If we try to do it lively, for example, in Boro, we need the one stream that we are right now broadcasting, and we need the reference, one more stream, and we need to sync them together and estimate. So first of all, we need the second stream. Secondly, that we need to synchronize them somehow, and the main problem that will lead to huge hardware performance required. So it will be extremely expensive. So usually such tasks is done during preparation of the encoder, transcoder, whatever. And after that, the encoder use the predefined settings 24/7 till the end of the life.
Okay, and the quality estimator, it's not creating these graphs, it's reporting the VMAP, PSNR, and SSIM scores. Is that correct?
That's correct. So we need to, actually, I calculated 4 times, but every time I calculated 3 metrics per time together. So
Okay.
at the result, I have the score plus plots in the quality estimator interface.
Okay, nice.
The next case is troubleshooting live stream. They're like, suppose we are receiving a live stream, we are transcoding it, and we are streaming it further, and our customers start complaining regarding visual video artifacts or dropped frames. And what could we do with such task? So for that reason, we have Boro. We need to determine whether we have the error on the elementary level, let's say video level, or we have the errors with the delivery on transport stream level. And we
So
need,
where,
yeah.
I'm sorry for interrupting. What's the configuration here? I mean, I'm a live streaming broadcaster. I've got a CDN, I've got Origin, I've got
Mhm.
remote viewers. Where do I put Boro to make these measurements?
You can put the Boro probes at any part of your network, before and after a transcoder, at the input of your head-on station, before and after multiplexer, packetizer, or modulator, even after the CDN. So we can track all the path that stream goes through. So what actually our customers done, they just need to deploy the Boro in their locations, and after all check in the web interface the location of error. And for example, on that screen, we have the transcoder location and two Boro probes before and after. And Boro probe detected a lot of TR101290 errors, like the common recommendation for validating transport stream. So we had a lot of errors before the transcoder, and even worse, it was the input of the head-on station. So from the beginning, we had a lot of errors that influence on entire chain for the channel up to the end viewer. And Bora proved their location and what exactly happened there. It was CC errors, so we lost some packets during delivery, and that packets contain video elementary stream. That's why the decoder wasn't able to decompress and then recompress their stream properly. That's why end users faced visual artifacts on their side.
Okay, so that points to the origination pre-transcoder that makes it simple to diagnose.
Right. And more, our customers are usually so confused and surprised that they have the problems from the beginning, where they think they're sure that everything must be good. And after that, they start working with their content provider, because sometimes the error happen on that point between content provider and IPTV or OTT operator. But the regular TR101 standard, it doesn't mean that in 100%, even if we don't have any errors corresponding to the standard, the stream is okay. And this is quite tricky question. And to detect that, usually we prefer file-based analyzers, because to dig in some such scenario, we need more details and in-depth analysis. How it works. Every video every video frame and audio sample, they have PTS presentation timestamp. So the moment where they should be presented. Such timestamps are used for synchronization between the video and audio, for streaming, and for during playback. But TR101290 checks only deltas individually separately for video elementary stream and for audio. But in our tool, in a StreamEye, Stream Analyzer, we can check not only the TR1290 and their how timestamps of video and audio increase. We can check we have like advanced tool which we call Tide Dynamics. Here on that panel, we represent the interleaving between video, for example, video frame and corresponding audio sample. What does it mean? For example, on that plot, I see the delta between audio and video almost 3 seconds. It means when I receive the video frame, I need at least 3 seconds to wait to obtain the corresponding audio frame. And that leads to latency and delay. But this is not the worst scenario. If we are streaming such stream to cable operators, like to DVB or ATSC, and they use hardware modulator. So such equipment usually has their hardware buffer, which has limited capacity. And with such stream, like their typical modulator will wait up to 1.5 seconds of the stream, and then it will start skipping the data. That will lead to a lot of errors in the log of their modulator or multiplexer. And the viewer will see it as the video artifacts and video-audio lip sync. And we have a lot of combination how we can check the interleaving between different timestamps. That was their timestamp video against the audio. But I have another example. The graphic of the video presentation timestamps is good, so everything is fine. At least we think so, and we don't have errors in TR101-90. But if we check the PTS and DTS timestamps, we see the negative deltas between them. Usually they should be like a linear, they should be the constant. But what it means, when we have negative delta, it means that their presentation timestamp, that the time when we should present the frame on the screen is earlier than their timestamp when the frame actually should be decoded. So this is ridiculous, and that leads to definitely problems during playback. And such things we can investigate and check using the StreamEye analyzer. That's why that tool was designed for quite deep and advanced analysis of especially transport stream.
So explain to me what I'm seeing on the screen that indicates that there's a problem.
Pardon?
Explain to me what I'm seeing on the screen that indicates there's a problem. So how do I know from this data that there's a misalignment between the presentation and the audio?
So this is the plot, and this is the deltas between video and audio. And on the plot, we see that the maximum delta is around 3 seconds and more, but it should be less than 1 second.
So in a perfect
stream, yeah,
it should be very, very close to the line, the midline.
It could be like it could have such shape, but it should be much less, 3 times less delta. This is the main condition.
Got it.
And here, the deltas between videos, presentation timestamp and decoding timestamp. We see that the maximum is 72 milliseconds and the minimum is minus 57 milliseconds. So in such points, the decoder will be collapsed.
Okay, thank you.
And the final case, but maybe the most common, its issues with ad insertion. Because when we work with the IPTV and OTT and cable television, every time we have ad insertions, and usually such companies, they have a monitoring system like Boro, and even they are monitoring ad insertion when it starts and when it finished, because their typical complaining from their viewers that during uh, they notice exactly when the ad insertion starts or ends. They see visual artifacts or even lip sync. And why such thing happens? We need to cover all of our chain with the monitoring system. Then we can track in each location when error starts and when when ad insertion starts and happens. Then we can use, for example, Boro for automatic recordings based on trigger, and the trigger would be ad insertion start or finish. So after all, we will have the files with the ad insertion inside, plus 20 seconds before and 20 seconds after. But in Boro, we need their exact timestamp, where the timestamp of the frame where ad insertion starts. Otherwise, we can use the stream analyzer. We can open such record there, find SCT35 ad insertion marks, and find their ad insertion precisely time mark. We need just a time mark, and we need it to find their corresponding video frame. So when we know the timestamp, we can open a video file in a StreamEye and find the video frame by such PTS timestamp. And there are two main cases when it happens, usually. The first case, that the ad was inserted with the open GP structure. So the GOP was open, and we merged together two different contents. And the encoder definitely, so not the encoder, the decoder will collapse in that point, because it's not like the same bit stream, it's just their ad insertion, it's different stream. It might be within different settings, even, I don't know, like different profile, even different resolution, different everything. We face so many different things, so it's crazy. And the second option is when ad insertion just put in somewhere in a GOP structure without even iframe, without even keyframe, which is crazy too. But that's what we usually face in a practice. So these are 4 typical cases that IPTV operators and broadcaster face when they work with file-based or live monitoring system. And for that reason, they use our StreamEye Studio or Boro. And we have more different cases at our knowledge base. So if you are interested, you can look at our website. And I invite you to face us in person this September in Amsterdam. We will be at IBC, where we will demonstrate demo of our products, of our StreamEye Studio and Boro and other tools, as well as we are going to showcase the workshop session there. So I invite all of you to come around and to join us there. Thank you.
Okay. Thank you very much. What do you're handling a lot of customer interfacing, I'm guessing. What are you hearing about codec usage out there? What are the requests you're hearing for AV1, versus 264 and HEVC and perhaps even VVC at this point?
Right. I communicate both with both sides, encoder developers and IPTV operators. So IP operators, they don't even think about AV1, VP9, and more modern codecs like VVC, LCVC, EVC, and others. They work with the regular MPEG second, AVC mostly, and just a little bit with HVC in case of 4K.
Okay. And on the ad insertion side, it seems like that analysis is best suited for client-side ad insertion. Is that correct? I mean, server side you wouldn't even see, right? That's kind of stitched at the server.
We are monitoring server-side ad insertion. So from the beginning, we have the hidden station where we put the ad insertion descriptors. Then we stream our channels to some states, and the local states receive the stream, and based on the ad insertion marks, then they insert local ad as there, and local ads what usually viewers get at their home, and we can monitoring it as well.
Okay. Alex, listen, this was great. Thank you for taking the time.
You're welcome.